Hello guys, welcome to this video on introduction to containerization. So before we look into this slide, first let's see a simple example. Imagine you are building a toy and you need different parts and tools to make it work. Now if you build this toy on your own table, it might work just fine. But if someone else tries to build it on their table using their own tools, the toy might not work as expected. This can be so frustrating and time consuming to figure out what went wrong. Now think about computer programs. They're like toys and they need certain tools and parts to run. And when programmers build these programs on their computers, everything seems fine. But when they try to run the same program on other computers, this might go wrong because those computers might have different tools and parts. So here's where containerization comes in. It's like putting your digital toy or all its tools in a special box. The box called a container has everything the toy needs to work. No matter where you open the box and set up the toy, it's guaranteed to work the same way. It's like a magic. The toy behaves the same no matter where you take it. So let's talk about containerization. Now you can understand this slide more clearly. So traditionally there is a problem when developers create a software application, they rely on various dependencies, libraries, runtime environments. However, those dependencies might differ between development machines, staging servers, and production servers, leading to a phenomenon known as it works on my machine, but fails in other environments. This inconsistency can lead to deployment issues, compatibility problems, and time-consuming debugging processes. Now, the solution for this is containerization. Containerization solves these problems by encapsulating an application and all its dependencies into a single package called a container. A container includes the application code, runtime, system tools, libraries, and settings required to run the application. This encapsulation ensures that the application behaves consistently across different environments regardless of the underlying host system's configurations. Now let's see some key concepts in containerization. The first is containers. Containers are lightweight, standalone, and executable software packages that contain everything needed to run an application, include the code, runtime, system tools, and libraries. They are isolated from the host system and other containers, ensuring that changes made within a container do not affect the host or other containers. The second one is Docker. Docker is one of the most popular containerization platforms. It provides tools to create, deploy, and manage containers efficiently. Dockers use images which are read-only templates that define the application and its environment. Containers are instances of these images that can be run, stopped, and deleted as needed. The third one is image. An image is a snapshot of a container consisting of the application code, runtime, and system libraries, and its other dependencies. Images are used as the basis of creating containers and can be versioned and shared across different systems. And the fourth is container orchestration. As your application grows in complexity and require more deployment across multiple containers, container orchestration tools like Kubernetes comes into play. Kubernetes automates the deployment, scaling, and management of containerized applications. It ensures its high availability, load balancing, and easy scaling. So now let's see some benefits of containerization. The first is consistency. Containers ensure that applications behave consistently across different environments, minimizing the works on my machine problem. And portability. Containers can run on any system that supports containerization. regardless of underlying infrastructure. Resource efficiency. The containers share the host system's kernel, which makes them lightweight and efficient in terms of resource utilization and scalability. Containers can easily scaled up or scaled down to meet changing demands, making them suitable for both small scale or large scale distributed systems. DevOps and CI/CD. Containerization facilitates continuous integration and continuous deployment pipelines, enabling rapid and reliable application delivery. So, in summary, containerization has transformed the software development and deployment by providing a consistent, portable, and efficient way of package and run applications. This technology has changed the software development lifecycle and enabled organizations to build and deliver applications more reliably and rapidly. So that's it for this video. Thanks for watching.